Hello dear students, today I am going to start a new chapter known as work, power and energy. From our earlier classes we know that something is basic about the work and the energy also and the work. Here on the point of view of not only board but also for the point of view of JEE, NEET and all the other competitive exams in India, I am going to take up firstly work as a specific term. So my dear children, what is work? Let's give me a simple example. Suppose that you are walking on a platform by carrying a suitcase on your head. Then, or a porter is carrying your suitcase on your head. So, in the language of physics, as work is not done by the porter in walking on the platform. Why? Because the force applied by the gravity, that is weight of the block, is perpendicular to the displacement. Then how will you say that for what I have to pay for wages? This is the very simple and technical definition of work. What do you mean by work? Work is transfer of energy under a specific condition. What is work? Work is transfer of energy under a specific condition. Work is transfer of energy under a specific condition. Let me explain by an example. Specific conditions. In every condition, transfer of energy is not doing work. You have to keep in mind, in every condition, transfer of energy is not doing work. For example, when sunlight is received by something and it is not moved, then how will you say that there is any work? No, there is no work. Okay, but there is a electromagnetic radiation in the form of heat energy is received by the body, but body actually not move. That's why this definition is termed as under specific conditions. So what is the specific condition? Let me give you an example. Consider a man A is pulling a block B of mass M by a force applying in the direction at this point of application. Consider a mass of a man A apply a force on block B, due to which block move through some distance, say this is x and this is y, and the distance between the two is s. What we will say that A applying the force, and due to this force block B moves from point x to point y by traversing a distance s in the direction of force. है ना? So in this case we will define the work done by A on the block B is equal to force applied by the man A on the block and displacement of the block in the direction of applied force. This is very simple definition of work done. So in this case, let me again explain the things. When A applied the force on B, it will transfer a amount of Fs joule of energy. A transfer Fs joule of energy to B, due to which block B move from A to B. So from where now a genuine question in arise, from where it get energy? He applied the force, he pulled the block. So in that case the man have utilized its chemical energy, which is converted into the mechanical energy, due to which this block B move from x to y. let us proceed further. I hope all of you understand well what is work. So what is work? Work is simply the transfer of energy under the specific condition. In this case, as A apply force B and B move from X to Y by a displacement S, then work is done by A on the block B is equal to force multiplied by displacement of the block. Let's give a more basic ideas regarding to work. Okay. Let us consider a different scenario. Consider a block of mass M pulled by a force making an angle theta with the horizon. Suppose that a block of mass M pulled by a force F by making an angle theta with the horizontal. So, as we know that from the knowledge of the vector, this force will be resolved into two components. One is along the line and other is perpendicular to the line, that is horizontal, x component, and this is the base component and this is vertical component. This is Fy. So what is Fx? Fx is F cos theta, and what is Fy? That is F sin theta. Fx is equal to F cos theta and Fy is equal to F sin theta. This is vertical component or Y component and this is horizontal or base component. And we observe practically, suppose that I am dragging a trolley in an airport, then or any bus station or anything else in our home, when pushing or pulling, then you apply the force in the direction, but the block actually not move inside the earth or in the surface, but it move along the surface. So what is the reason? It means this is not responsible for the movement of the block, while the force which is responsible for the movement of block is F cos theta. That's why if in time t block is displaced through a distance this to this, then W is equal to, now I am going to explain this in a very specific term. My dear children, you remember always one more formula for it: displacement of the block into force in the direction of displacement. Force in the direction of displacement. This is another way. Or you may say that now I am going to take up the vector scenario of this formula that you earlier you learned in previous slide, that W is equal to F into S. This is displacement of block into the force in the direction of the displacement. Okay. So what is displacement? This is S. And what is the force? F cos theta. So now the formula is Fs cos theta. We know that in between the two vectors, if there is a cosine of the angle, then we can write it dot product, that is F dot S. This is the vectorial notation of force. You can take up this is also by another method. Let me explain further. Please note it down. That is F cos theta. Then we will talk about the reference frame and another thing related to this, and simultaneously we proceed further and further regarding. Okay. Suppose, my dear children, let us suppose that I have an inclined plane like this, an angle phi. This is the angle phi, and I am dragging a block by applying a force F in this direction. Okay, but as you know, let us suppose that this force F is acting on the block in horizontal direction always, from at t is equal to 0. It is not important here or to take the time, but in my point of view, if you are taking the time simultaneously, then you can understand the concept very well. Suppose that when we are start dragging this block on the verge of the plane, then the time is t, and after time t, this block is here. Okay, so if this is the distance s, then you can write it as s cos phi. Now my dear children, again we can write a formula for work done. Work done is equal to force into displacement in the direction of force. Okay, this is F into S cos phi. Okay, so again from the previous slide we can write F dot S here also, W. This is another formula. So this is a very simple and basic formula. Here it is essentially noted that F is not variable. F is not variable. Here I assume that F is not variable. F is all time have a constant value. Okay. Before proceeding further, I would like to introduce the SI unit and dimension for the important point of view of NEET and JEE Main. That is the important, and some commonly used unit of work. The SI, note it down. The SI unit of work is Newton meter. No. Not write Newton meter. Write it as Joule. My dear children, always remember that Newton meter is SI unit of torque. It is internationally applied pure and convention के according this is the SI unit of torque. So we will always write the SI unit of work is as Joule. So 1 Joule is equal to 1 Newton meter. You can simply define if on the application of a force of 1 Newton, if a block moves through a distance of 1 meter, then work is said to be done by 1 Joule by the external agent. Okay. Another commonly used unit, 1 kilojoule 10 to the power 3 joules and 1 megajoule is equal to 10 to the power 6 joules. My dear children, I am taking care about the two more units here. Remember always 1 electron volt. It will be discussed later because this is the atomic unit of energy. 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule and 1 mega electron volt. 1 mega electron volt is equal to 1.6 into 10 to the power minus 13 joule. These are the two units commonly used in atomic level. Okay. So sometime in many of the books you observe that for work is classified. Work is a scalar quantity, so classified as a positive work, negative work, and zero work. Okay. Let me give you another idea regarding to it. Now take the previous example again. Let us suppose that this is a man A applying a force on block B. Okay. So according to Sir Isaac Newton's third law of motion, every action have equal and opposite reaction, and action and reaction act on two different bodies. My dear children, as the instant when A apply a force F on this block in this direction, say this is the force F applied by A on the B. On same time B apply a force A on this direction. Okay, because this is the law of nature. Every action have equal and opposite reaction. So whenever A is apply a force on B, B also apply a force A. We will see further whether suppose that I am pushing a wall, then wall is not moved. Obviously wall is fixed. But what do you mean by it? I am not applying force, or wall is not applying the force on me. Both are applying the force on each other, but because there is no movement, so work done is zero. But the force are applying by the both the blocks simultaneously, both the agents simultaneously. I mean to say that A on B and B on A. Okay, so let us suppose that due to this applied force of man on the block move from A to B position, sorry, X to Y position by traveling a distance S. My dear children, if work is done by external agent on the block, so what is the force? This is FAB. Say in terms of magnitude, this is F. Okay, so FAB okay, into S. And what is the angle between AB and S? This is cos 0 degree. So this is positive. And the formula is okay. At the same time, when block is here, what is the display? What is the force work is done on the external agent, by the block. So let us see here. FBA is directed towards the left, and the displacement of the block is toward the right. That means FBA, which is also in terms of magnitude equal to F, say, and S, this is cos 180 degree. So this is negative. It means positive and negative work done is positive and negative work is existed simultaneously. You can't say that if, whenever a block is doing positive work, it is not necessarily doing some negative work there. Mark my point. Positive work and the negative work existed simultaneously. Both are existed simultaneously. Okay. So, and in this term, one more thing you have to note it down. Work is done external agent by the block, and this is a positive and this is negative. So it means Fs joule of energy is transferred from the man to the block. Okay, from the man to the block. Fs joule of energy is transferred from man to the block. Remember, or you may note it also. You should note it. When A does work on B, then there will be a transfer of energy from A to B. And what is the word transfer of energy? Fs, joule of energy. So from here, can you see me that? Can you say that? What is the which will gain energy and which will lose energy? Obviously, A will gain energy and A will lose energy and B will gain energy. A will lose energy and B will gain energy. You got my point? Okay. Now, next we are going to the next slide. You should write the 2 points. One is positive work and other is negative work. What is positive work? Positive work means supply of energy. Positive works means supply of energy. Supply of energy. And what do you mean by negative work? It means gain of energy. Always remember these two facts. And positive and negative work existed simultaneously. My dear children, I am giving you the more picture. I am giving you the more clarity of this concept. Before proceeding further, consider a block of mass m kept on a rough surface. Obviously there will be a friction. Okay. So suppose that due to application of this force F, block move through a distance S. Okay. Block move through a distance S. Now calculate work done by different forces. Have a look. Before I solve this question, I would like to give you the clear insight regarding to this problem. What is asking? Suppose a block of mass m kept at a rough surface having the coefficient of friction mu, due to the application of force F. Let us suppose that this is the angle made by the F with the horizontal is theta. Then now draw FBD. You will get the clear idea how many forces actually acting on the block, in this case. So as F will be have two component, one is Fy and one is Fx. Fy is equal to F sin theta and Fx is equal to F cos theta and mg. Okay, and as block is moving in this direction, so friction on the block act on in this direction. I am just asking about the work done by the all forces acting on the block. That's why we will neglect the work done by the friction on the ground, by the block. Okay, so this is the friction acting on the block due to the ground, and you know that friction is also acting pair. So for the first force, if we talk about the F sin theta, then here I am going again another concept of zero work done. Okay, so as angle between Fy and S is 90 degree, so Fy is equal to 0. Mark my word. So for the zero work done, there are three possibilities. What are the three possibilities? Either there is no force applied, either there is no displacement due to application of force, or force are applied, there is a displacement, but the angle between the force and the displacement is 90 degree. At the same case, when I am starting my lecture, I told you you are dragging a box and taking your head, or your porter is dragging the box by taking it on his head. There is no work done in the sense of physics. Yes, no doubt there is a transfer of energy. We will discuss this later. So Fy is equal to 0. On the same line of discussion, you can also say that as the angle between the mg and S is 90 degree, so Wmg is also equal to 0. Here is the example. Okay, so now we can write here as a note W may be 0. W may be 0 if, here is a three condition: if F is equal to 0, if S is equal to 0, or if theta is equal to 90 degree. Here on the same concept, there is a lot of question asking JEE Main and NEET, that is, suppose that you have a fixed ceiling by which a bob of mass m is suspended through a string of length L. Okay, and this bob is pushed by a Q, and it is moved from here to here by an angle theta. Then, very simple language, it will be discussed more and more in great detail in circular motion about this specific condition. I am just giving an idea that if you are especially talking about the tension in the string, then the angle between the T and the displacement at every moment will be 90 degree. That's why the work done by the tension is 0. It is an example. You must note it down. Okay. The tension, the work done in this specific case is 0. Another example you can take. Suppose a body is revolving on a circular track, and this is the centripetal force. I am not going into great detail for here, but for the simplicity, any point you can draw this figure, and at every point the displacement and the force at 90 degree angle, so the W is 0. It is just example of the work done. Okay. Now come to the positive and negative work. If we talk about this force F cos theta, if we talk about this force F cos theta, then W Fx is equal to F cos theta into S. This is the positive, and cos 0 degree. So this is positive work done. And let us first find out what is the friction acting on the block, so that when we calculate the value of friction, we multiply it with the displacement and the angle between them, we will find out what the work done by the friction. Okay, so as we know that in this case, friction Fs is equal to mu s n, where n is normal. Where is n is normal, and what is the value of normal here? Brother, again, mg here acting is here, and normal reaction is here. So what is the Fs? Fs is equal to mu s n. So this will be mu s n. Let us consider the case of limiting friction, mu s mg. I am just giving an example, so not going into great detail. So Fs is equal to mu s mg. In this case, if you talk about work done, then W is equal to Fs into S cos 180 degree. This is minus Fs into S. My dear children, in one example, I explained the three different nature of work done. One is zero, and one is positive, and one is negative. Okay, we will proceed further in the next slide.